Hello guys, let's solve the equal problem. So there is given an array of numbers. We can add 1, 2 or 5 to all of the elements except 1, and the requirement is in the fewest possible steps have an array having equal elements. Here, for example, we have 4 numbers 2, 2, 3 and 7. We can add 1 to all elements except the third one, so it will be 3, 3, 3 and 8, and then add 5 elements to all except the last one, and all the elements will be equal. This problem is in this section of dynamic programming, but we will solve it with a greedy approach. So what does it mean to add to all elements except except the one? It just means to let all elements the same and decrease the one element given that number. So instead of adding 1, 2 or 5 to all except 1, we will just decrease 1, 2 or 5 from the 1. To make calculations simple, let's at first find the minimum value in the array and decrease it, so we will have just the differences. So we need to find the number of steps after which our array will become 0. So let's declare our ans. We will return ans. Let's define our m equal to r0 and traverse all of the array and find the minimum element if m is more than re, m equals to re. So we have the minimum element. Now we need to traverse all of the array and so we need to do it greedily, so we should subtract 5 until the number is less than 5, then subtract 2 until the number is less than 2, and then subtract the last one. So we need just to add re divided by 5, then add re modulo 5 divided by 2. For example, our element equals to 9. After this step it will become the answer will increase by 1 because we have used 1 5 element, and then we will have 4. So then we will subtract 2 times, and by 3 after 3 iterations we will have 0. So at last we just add element modulo 5 modulo 2. So I think that's it. Let's check it. The sample test case has passed. Let's submit the code. Let's see what our code returns. 13155. It returns 4. If we subtract 1 from all the elements, there will be 0, 4, 4. Then we will need to actions for each of. So how we can solve this? Actually, we can add 2, 2, so 3. No, we cannot. Five, 5, 1. 5, 5, 1. So we can add 5, 5, 10, 6, 5, then 5, 5, 11, 10, 10, then 1, 1, and it will be so maybe we just shouldn't subtract the minimum. We may subtract minimum minimum minus 1, minimum minus 2, and so on. So let's try this out for j equals 0, j less than 5, j plus plus. Let's move this up. Our current answer is in 32. And current answer becomes 0. Current answer is element equals to re plus m plus 3. Current answer is element divided by, what's the problem? M is j is or j in 32. So this is also element, so that's it. What's the problem? So after this, this is current answer. If current answer less than ans and ans is not 0, or ans is 0, then answer becomes current ans. So we'll get the minimum. What's the problem? Let's run the code. So this test case has passed. Let's submit the code. So what's the problem? This is the biggest test case. Expected output. Where is our output? So it requires to return int 32. So it can't be an overflow. 10,000. This that ans let ans be equal to 32, 31. And 32. Alright, let's just take a bool value. This should work now. That's it. I just checked here if once has been overridden or not. So that's all. Thank you.